Hello, good morning, good evening, good day to everyone. Welcome to join this webinar co-organized by the World Federation of Engineering Organizations, WFEO, and FIDIC, the International Federation for Consulting Engineers. My name is Gong, the president of WFEO, will be moderate today's webinar. This webinar is to discuss the proposed amendment to the current graduate attributes and professional competencies of engineering education specified by the International Engineering Alliance. We also call it the Washington Accord, Sydney Accord, and other accords. The proposed amendment comes from a joint project of IEA and WFEO to review the current GAPC, that's the acronym for the graduate attributes and professional competencies. In the new context of the UN Sustainable Development Agenda and in the context of the fourth industrial revolution. So today we have 5 speakers and followed by a short questions and answers. First, please allow me to invite William Howard, the president of FIDIC, to give an opening address. William, the floor is yours.
Well, thank you very much, Gong, and I will be very brief because we want to get to the main portion of the program. First of all, on behalf of FIDIC, I would like to welcome everyone for participating today in this very important webinar. The subject is always very important to look at graduate education, continuing education. For any profession, we really need to look at that. And I think this time that we're in is particularly pertinent to look at that subject because, as we all know, the world is changing dramatically. The terrible pandemic that we've been involved in the last year or so is changing all sorts of things. The best comment I've heard on it, or the most probably interesting comment, is no one knows where this is all going to lead. But we all know it's going to lead to change. And we need to be, as professional engineers, we need to be on top of that change because we are going to be asked to do all sorts of things with all sorts of people. And I think the opportunities are just going to be dramatically great for us, and we need to be prepared for it. I think that we're going to be entering into very exciting times. And finally, I would like to thank the World Federation of Engineering Organizations for reaching out to FIDIC. Marlene, you in particular led the charge on that. And we have a partnering agreement with the World Federation of Engineering Organizations, not to get into too much detail, but one of the things that we're trying to achieve at the FIDIC board level is to communicate much better with our colleagues and other engineering organizations and stakeholders. This is a wonderful step in that direction. So thank you to all the speakers for participating today, and thank you for allowing me to say a few things. So back to you.
Thank you, William, for your kind words. And we do expect a closer collaboration between WFEO and FIDIC. William has a wealth of global experience in executive leadership, quality management, training, and risk management. And he began his 2-year term as the president of FIDIC in September 2019. And we hope under your leadership, we could build a closer collaboration between our 2 organizations. Now, please allow me to announce that we have in the chat box a link to a Google Doc where is a sheet for questions and answers. These answers posted in this on the Google Doc will be answered during or after the webinar. Please use this sheet to pose your questions. Now, please allow me to invite Dr. Marlene Kanga, the immediate past president of WFEO, and she is the leader of the WFEO team in this joint project with IEA. Marlene, the floor is yours.
Thank you very much. And I'd like to add my very warm welcome to our colleagues from FIDIC and President Bill Howard, Stephane, Giraud, and Adam Bialachowski. We really very thrilled to have you, and this is a very important consultation webinar for our project. So we welcome you warmly tonight. So I will now share my screen. I hope you can see my slides. So yes. My presentation, I will go quite quickly. We'll have 3 parts. I will give a brief introduction to WFEO for those who are not familiar with the World Federation of Engineering Organizations. And secondly, I will give a brief overview of the project that we have worked on with our partners at the International Engineering Alliance. And thirdly, I will give an overview of the proposed changes for graduate engineering education. And my colleague, Professor Tan, will talk about the professional competencies which occur after graduation, and which is, of course, of great interest to the employers that are members of the consulting organizations that are members of FIDIC. So the World Federation of Engineering Organizations is the peak body for professional engineering institutions, founded in 1968 under the auspices of UNESCO. We have some 100 national professional engineering institutions and 12 international and continental regional institutions as our members, representing some 30 million engineers. And you can see here our member map. We are a recognized NGO at UNESCO, and we co-chair the Science and Technology Major Group at the UN. And we have representation at all the major UN organizations. So as a leader for engineering globally, a key objective is to advance the UN Sustainable Development Goals through engineering, because we believe that every one of these goals requires a component of engineering. But to do this, we need to have more engineers with the right skills to develop the technologies and engineering solutions that we need for sustainable development. And this project, in fact, is one of partnerships with our peer international organizations, so Goal 17. And of course, it's about education, which is Goal 4. So the World Federation of Engineering Organizations has partnered with our international peers. And you can see here our partnerships with the International Engineering Alliance, with the International Federation of Engineering Education Societies, with FIDIC, the Federation of International Consulting Engineers, and with other international groups, including InWest, which represents women, and other UNESCO Category 2 centers involved in education and capacity building. The International Engineering Alliance is an umbrella organization that provides governance for 3 accords and 4 agreements. And these enable international multilateral recognition or mutual recognition of graduate attributes on engineering education graduation, and after graduation, the professional competencies that are required across some 30 countries. The framework that drives this mutual recognition covers professional engineers or a 4 to 5 year qualification period, the technologists with 3 to 4 years education after school, and technicians for 2 years. And there are corresponding agreements for professional competencies. The International Engineering Alliance has a benchmark for the expected graduate outcomes after a period of study in a tertiary institution, and the professional competencies after graduation. And this review of this benchmark is the core of the work that we've been doing in partnership. WFEO has an MOU with IEA and has established a working group to carry on this work. And UNESCO also supports this work. And the second UNESCO engineering report, due for release in a few weeks' time on World Engineering Day, makes the recommendations that governments, engineering educators in industry and professional engineering institutions need to collaborate to increase the number and the quality of engineers. So it's not just quantity, but quality that's important. And in the context of FIDIC, we need to graduate engineers that are employable and that have the skills that employers are seeking. We have here the members of the working group, and I don't propose to go through them all, but just to say that we have the time frame down the bottom. We've been working since late 2019, and we presented a draft of the proposed changes in June 2020. Since then, we've been consulting with our peer organizations, and we propose to finalize the proposed review and hopefully get an approval at the annual meeting of the International Engineering Alliance in June 2021 and the WFEO General Assembly in October 2021. So why the review, and what's the imperative for this review? We did a lot of research at the start of the project, and there was general agreement that core knowledge, skills, analytical background, and knowledge that's specific to a particular engineering discipline would continue to be needed. But there's growing rapid changes, as has just been mentioned by President Bill Howard. Things are changing very rapidly, and no more rapidly than in the IT area, where the ability to write code, rely on new technologies like 3D printing, information literacy, media literacy, will become core to all engineering education. Data-driven analytics, digital proficiency, and digital learning platforms will be used more and more. But also liberal arts training will become important, and engineers will need to be cognizant of social, legal, and economic issues. The complexity, scale, diversity, globalism in engineering problems will increase, and we'll need more inclusive and sustainable solutions. And engineers will need entrepreneurial skills. They'll need to know how to take risks and to think critically. They will need to work in diverse teams, also in remote and virtual workplaces, as we've discovered in the last 12 months as in the COVID-19 pandemic. And of course, artificial intelligence, machine learning, automation, and so on will have rapid growth. And you can see here, as we look ahead to Society 5 and all the new technologies that are going to come through, every one of them impacting on the Sustainable Development Goals. We have big data, Internet of Things, AI, robotics, drone technology, sensors, 3D printing, etc., 5G, virtual reality, augmented reality, and so on. And so engineers are going to more and more have the ability to learn new things, because there's no way a 4-year degree is going to cover everything. And of course, we have the rapid advances in mobile technologies. You can see here, 2015, we had 4G, 2030, 6G, and 2050, 8G as population grows. This is Moore's law continuing to grow very rapidly and making these technologies very accessible and low cost. And we see the changes in various disciplines. And you see here a CAD drawing for civil engineering structure. And it's estimated that 90% of the work of civil engineers is embedded so well in codes that simple designs can now be automated and done in a matter of hours, where it took many months before. And technologies like building information modeling and simulation are now being used increasingly to transform engineering and do tasks that need very little human intervention. And you can see here again, the impact of 3D printing for modeling of buildings, modeling flood mitigation plans, predictive analytics, and all these information technology tools are going to be increasingly used. And of course, The digital drawings have now become standardized. For example, in the state of New South Wales, where I live, all construction drawings will have to be in digital format from 1st July 2021. And of course, engineering is changing in other ways. We need more brain power, not muscle power, and engaging more women in the race for new technologies and more engineers is on in all around the world. FIDIC, of course, as the global representative body of the National Associations of Consulting Engineers, represents over 1 million engineering professionals and 40,000 firms in 100 countries worldwide. The members of associations of FIDIC are the employers of engineers around the world. And so this webinar is an opportunity for employers to comment on the changes that are proposed to graduate attributes and professional competencies of engineers. This is the first time that employers have had the chance to make comment. And in the future, we hope FIDIC will work with WFEO in capacity building in the training of engineers and the development of professional competencies that align with the benchmark that we're discussing tonight. And young engineers in particular, we hope, will be particularly interested in the proposed changes as they develop their careers. So the benchmark overview of the changes covers 6 main areas: accommodate the future needs of engineering professionals, look at emerging technologies and incorporate digital learning, lifelong learning, address emerging and future disciplines and practice areas while retaining a discipline-independent approach in the framework, and develop skills, especially in data sciences. Incorporate an approach to the UN Sustainable Development Goals so that engineers consider diverse impacts of their work: technical, environmental, social, cultural, economic, financial, and global. Consider diversity and inclusion in its broadest sense. Look at working in teams, communication, compliance, environmental systems. And finally, develop the skills for intellectual agility, creativity, innovation, and critical thinking. The GAPC, or Graduate Attribute and Professional Competency Framework, has 5 tables. I don't propose to go into the detail, I will just provide an overview. So the table 1 describes a range of problem-solving capabilities for professional engineers, technologists, and technicians. Table 2 similarly talks about the range of engineering activities for the 3 categories of professional. Table 3 is a knowledge and attitude profile of a graduate, and table 4 is the graduate attitude profiles or the outcomes that an engineering graduate will be expected to have achieved on graduation. And finally, we have the professional competency profiles that specify the range of competencies for a qualified engineer, technologist, and technician at the point of registration. And it is this table that is of greatest interest to employers as engineers progress in their careers. So very quickly, at university, the graduate attribute profile covers 12 elements. The first 5 is about the basic engineering knowledge, problem analysis, design and development of solutions, investigation and research, and the use of appropriate tools. Then we have how the engineer interacts with society and considers the human, social, and environmental impacts, as well as ethics of their work. And finally, we have how the engineer works. And this, of course, ways to work will inform how that engineer works after graduation when they're out there in the workforce. So changes have been made to all 12 elements, and we have the details on our consultation website. And we ask you to visit the website and take a look, provide your feedback, and please let us know what you think by the middle of February, the 15th of February. Thank you.
Thank you, Marlene, for your brief but comprehensive introduction of the review work, and also a brief introduction of WFEO. The next presentation will be given by Professor Charlie Tan, who is the president of the Myanmar Engineering Council. that accreditates the engineering education institutions in Myanmar. And he is also the member of the WFEO Executive Council and chairing the WFEO Committee for Engineering Education, which is leading the efforts of WFEO in engineering education. He will present the proposed changes to the professional competencies, that is table 5, just mentioned by Marlene. Charlie, the floor is yours.
Thank you. Please allow me to share my PowerPoint.
Good.
Good morning and good evening. President of the World Federation of Engineering Organization, and also President of the International Federation of Consulting Engineers, FIDIC, and immediate first President of the World Federation of Engineering Organization, Dr. Marlene Kanga, and Mr. Stephane, Chair of the International Federation of the Consulting Engineer Capacity Building, and Mr. Adam, Chair of the International Federation of the Consulting Engineers Future Leader Council. Please allow me to present my presentation on the UNESCO IEA WFEO draft review of the IEA Graduate Attribute and Professional Competency Framework, especially on the table 5. Next slide. I am Charlie Tan, President of the Myanmar Engineering Council and the Chair of the WFEO Education Committee. Today, I would like to present the proposed changes to the Table 5 of the Professional Competency Profile. Next slide. There are the 12 elements of the graduate attributes divided into 3 categories, which are Washington Accord, Sydney Accord graduate, and Dublin Accord graduate. The level of graduate attributes for Washington Accord graduate is complex. The level of Sydney Accord graduate is broadly defined, and the level of Dublin Accord is well defined. Next slide. These are the 13 elements of the professional competency profiles divided into 3 categories known as a professional engineer, engineering technologist, and engineering technician. The level of professional competency profile for professional engineers is advanced. For engineering technologists is widely accepted, applied, broadly defined, and for engineering technician is standardized and well defined. Next slide. This is locating the graduate attribute and professional competency in the engineering pathway. When an engineering student is graduated from an accredited program, the student will meet the standard for engineering education known as the Washington Accord for the graduate attributes in IEA definition, which is also known in meeting with the standard for engineering education in national definition. When the graduates, engineers obtains training and experience, the standard for professional competency in national definition or professional engineer competency profile in IEA definition will be obtained. Then the engineers will continue their practice while observing the code of conduct and maintaining CPD. Next slide. The working group has made several amendments to the professional competency profiles. The amendments are highlighted in yellow. The working group proposed that there will be no personal pronouns being used in the context. Instead, general, gender-neutral language will be used throughout the context. The professional competency profile is to meet the minimum standard of competence. A person must demonstrate the ability to practice competently in their practice area to the standard expected of reasonable professional engineer, engineering technologists, and engineering technicians. The extent to which the person is able to perform each of the following elements in their practice area must be taken into account in assessing whether or not the overall standard is met. Next slide. The working group do not propose any changes to the first element of the professional competency profile, which is to comprehend and apply universal knowledge. Next slide. For the second characteristics, to comprehend and apply local knowledge, except for the change to use gender-neutral language, is suggested, and the using of personal pronoun for all three EC2, DC2, and C2 are eliminated. Next slide. For the third element, problem analysis, the use of data and information technologies has been added for professional engineers, and the use of support of computing and information technologies has been added for engineering technologists and technicians. Next slide. For the fourth element, design and development of solution, the importance of inclusive solution and stakeholder consultation has been added to EC4, design or develop inclusive solution to complex problem with stakeholder consultation. And inclusive has been added to DC4 and NC4, which become design or develop inclusive solution to broadly defined problems. Next slide. For the fifth element, evaluation, the importance of the evaluation and risk assessment in broad context has been added for professional engineer. Evaluate the outcome and impacts of complex activities in the context of the risk and social, environmental, economic, and resource impacts. And for engineering technologists, evaluate the outcome and impact of broadly defined activity in the context of risk and social, environmental, economic, and resource impact. Next slide. For the sixth element, protection of society, types of activity and responsibility to consider adding advancement of the UN SDG and eliminating the word public. The importance of consideration of the advancement of the UN SDG where relevant has been added to EC6, which is recognize the reasonably foreseeable social, cultural, and environmental effects of complex activity generally and have regard to the need for sustainable outcomes that leave no one behind per the UN SDGs, global quality of life for humans and the environment, eliminating, recognize that the protection of society in the highest priority in TC6. Recognize the reasonably foreseeable social, cultural, and environmental effect of broadly defined activities generally and have regard to the need for sustainable outcomes that leave no one behind per the UN SDG, global quality of life for human and the environment, eliminating sustainability. Take responsibility in all these activities to avoid putting the public at risk. And in NC6, recognize the reasonably foreseeable social, cultural, and environmental effects of well-defined activities generally and have regard to the need for sustainable outcomes that leave no one behind per the UN SDG, global quality of life for human and environment, eliminating sustainability, use engineering technical expertise to prevent dangers to the public. Next slide. For the seventh element, legal and regulatory, environment and cultural has been added to the characteristics which become legal, environmental, cultural, and regulatory. The importance of the compliance with the relevant laws and regulations, including to protect the environment and cultural heritage and gender-neutral language, had been added to EC7, TC7, and NC7. Next slide. For the eighth element, ethics, diversity and inclusion had been added to the characteristics, which become ethics, diversity, and inclusion. The ethics of equal opportunity for all through working effectively in diverse and inclusive teams and gender-neutral language has been added to EC8. Conduct all activities ethically and inclusively, respecting cultural, ethnic, religious, and all other differences. EC8, conduct all activities ethically in diverse team and understand the need for inclusion. And NC8, conduct all activities ethically in diverse team and understand the need for the inclusion. Next slide. There is no changes in the 9-element managed engineering activities. Next slide. For the 10-element communication, the working group added collaboration requirement for the inclusive communication to the characteristics. The importance of inclusive communication and gender-neutral language has been added to EC10. Communicate and collaborate using multiple medium, clearly and inclusively with a broad range of stakeholders in the course of all activity. TC10, communicate and collaborate using multiple mediums, clearly and inclusively with a broad range of stakeholders with others in the course of all activities. And in NC10, communicate and collaborate using simple mediums, clearly and inclusively with a broad range of stakeholders with others in the course of all activities. Next slide. For the 11th element, lifelong learning has been eliminated, substituting continuing professional development, CPD. The importance of lifelong learning in the world of rapidly changing technologies and gender-neutral language has been added to EC11. Undertake CPD activities sufficient to maintain and extend technical competency and enhance their ability to adapt to emerging technology and the ever-changing nature of work, eliminating sufficient to maintain and extend his or her competency. TC11, undertake CPD activities to adapt emerging technologies and the ever-changing nature of work to maintain and extend competence. And NC11, undertake CPD activities to adapt the emerging technologies to maintain and extend competence. Next slide. For the 12th element, judgment, the need to exercise judgment and application of knowledge and ability in broad context and gender-neutral language has been added to EC11, recognize complexity and assess alternative in light of competing social, economic, environmental, cultural, and other requirements, and considering incomplete knowledge. Exercise sound judgment in the course of all complex activities. TC12, choose appropriate technologies to deal with the properly defined problems, considering social, economic, environmental, cultural as needed. Exercise sound judgment in the course of broadly defined activities. Next slide. There is no changes in the 13th element, responsibility for decision. Next slide. The presentation above is the proposed changes to the Table 5 of the Professional Competency Profile of IEA. You can see that changes that the proposed are small and strategic. They shift the focus of the engineer to also include impact on society, environmental, and economy, learn to communicate and engage with stakeholders, work in team and engage in lifelong learning, especially in new technologies. We hope that these changes will help the engineer to meet the needs to the community and society now and in the future. Thank you.
Thank you, Professor Tan. Our next speaker is Stephane Giraud. who is the chair of the International Federation of Consulting Engineers, FIDIC's Capacity Building Committee. And he will talk about the overview of the new training and accreditation strategy of FIDIC as to future leaders, contract managers, consulting engineers, trainers, and dispute avoidance and adjudication boards. Stephane, the floor is yours.
Yes, thank you very much, Professor and dear Presidents. So I am Stephane Giraud, I am from France. I am an engineer and I work as an engineer. I am also accredited trainer and accredited adjudicator for FIDIC. And actually today we speak about the capacity building because I was appointed last year as responsible, the chair of a capacity building committee of FIDIC, which is a group of approximately 10 people to work from all around the world on the specific subject of capacity building, which is very wide. And this is why it is linked with the seminar and the webinar of today. And capacity building with FIDIC is about how to enhance the capacity of the employers, but also the engineers and the contractors, for instance, in the construction industry or in the engineering field. And for that, we are working on a lot of different aspects, and we are closely linked with some member associations throughout the world. We try to collect all the needs from them and try to respond with specific accreditation, certification, or modules of training. So today I will specifically speak about the new groups of people and the new organization inside FIDIC called FCL, FIDIC Credentialing Limited, which is a separate company from FIDIC, specialized to certify people. So in that sense, it is important to understand that there are different paths inside FIDIC to become some with some certification. So I will share my screen on this. As to certification, FIDIC would be very soon, because it is ongoing works, FIDIC would be in a position to propose to all engineers in the world 5 different paths. And you find on this slide that the first one is FIDIC Future Leaders, as to competencies and development of competencies in the use of FIDIC contracts and in business leadership. So obviously, FIDIC is well known about the contracts, but not only for that. It's about all the business and also the how to be an engineer. And on this specific future leader certification, Adam, my colleague from FIDIC, will explain more details just after me. The second path is FIDIC Contract Manager. It is a new certification. It is as to competencies how to manage a FIDIC contract, to be sure that whenever there is a FIDIC contract signed between an employer and a contractor in a specific country, the parties are well staffed in-house with a competent contract manager to run the project. The third one is FIDIC Consulting Engineer. It was developed a few years ago in China, and the pilot program was done in China, which is a very strong modules to train engineers to become FIDIC Consulting Engineer. The fourth path is about trainer, how to become a trainer for and on FIDIC contracts and on FIDIC specific modules. It's competency to train. And the fifth one, it is called FIDIC Adjudicator. It is the specific dispute resolution path FIDIC had developed for the last 20 years. And the adjudicator is someone who had has two hats. First, trying to avoid dispute by giving some opinions, and second path is when the adjudicator has to take a decision in a dispute before going, in case people are not agreeing on that, onto some arbitration later. So for that, FIDIC has developed also a specific path to become adjudicator. And there is a specific group also called the FIDIC Precedent List of Adjudicator to decide onto some disputes on contracts. So all these 5 certifications are actually under a strict methodology, which is inspired and totally in light of the ISO 17024, which is a way to be sure that FIDIC is certifying people in the right way in terms of methodology and standard. The next slide, if I can move it. Yes. It is about this ISO standard, and to be sure that the credentialing is well done, then the certification has to go through 7 tasks, which is the insurance of defining the scope and of certification first, then the job description, what is the engineer has to do during his professional career. And the third one is the prerequisite to apply. 4th is competencies. So this is the benchmark we heard from GAPC is quite similar. What are the competencies and also what are the outcomes? So there is a parallel to do with what we are talking about in this webinar. And assessment methodology, how to assess that the engineer is capable and competent. And then 2 slots, 6 is recertification after a certain period of time as a CPD also. And the 7th one is a code of conduct. And to give just an example of what is going on at FIDIC, I wish to share the next slide, which shows it is a draft version, because just be sure that what I'm showing today is ongoing works, it's not final works. But you see that for specific here certification, you have to try to pass or to attend some specific modules. So we called for the moment some modules 0, 1, 2, 3 as to specific competencies or outcomes, learning outcomes, out of which you may be in a position to apply for specific certifications. And you see that there are some specificity on contract management, on construction project, but there are also how to train people. Here, module 5, it's ongoing, it's to be created. I'm talking about in the near future, contract management, but also some business practices and future leader. And you see that all this is ongoing. This is a job, FIDIC is having a lot of volunteer jobs around the world to add several bricks and to try to have at the end a nice and coherent FIDIC training tree. So this is now the opportunity for me to leave the floor to Adam, who will explain more specifically what is the Future Leader program. Thank you very much.
Thank you, Stephane. The next one is Adam Bialachowski, who is the chair of the FIDIC's Future Leaders Council, and he will talk about future leaders and keeping engineering education and professional development for contemporary and relevant for young engineers, future leaders, and current employers. Adam, the floor is yours.
Thank you very much. It's a pleasure and honor to be here. So thank you to the WFEO, Dr. Kanga, Mr. President, for having me. Thank you for FIDIC for being able to contribute to these great organizations. If I could ask to share my presentation. My name is Adam Bialachowski, and I'm currently the chair of the Future Leaders Council within FIDIC. And parallel to that, I'm also a current employer. I'm a CEO of a group of consulting companies that employs over 100 people in Central and Eastern Europe. So I'll be talking from both perspectives and how does this fit into the new proposed framework, the changes to the framework, and how does this fit with FIDIC's education scheme. I will do it from 4 perspectives. So we have the future leaders perspective and the questions that future leaders ask themselves while contributing to the workforce. So what are we looking for? How young engineers and project managers fuel their passion, and also how education impacts this. What do future leaders, young engineers want from employers? I'll also talk about the perspective of current needs. So what are actually the projects that are in my part of the world going on, and how the market needs a bit of change from education, how COVID sped up certain aspects of delivering work, and how new requirements and new services are generally appearing in our industry. And that fuels the perspective of the employers who have a changing market, and what do they need from young engineers and future leaders? What do employers expect from education institutions, and how employers and educators can provide for this new work environment? And that nicely ties in with the framework and the changes that were discussed by Dr. Kanga and President Tan, and how FIDIC is proposing to go about certifying also our profession. And why is this important in this proposed solution? So next slide, please. So future leaders, it's also with a generation change. It's looking for engagement and belief in what we're doing in innovation and in social interaction at work. This fits in nicely with green projects and the care for environment, because the younger the generation, the more it seems in my part of the world that engineers care about the environment. We are pretty technologically savvy, but we need help from our senior colleagues to sometimes get the ball rolling. Enabling work from home was a big thing before COVID, and many companies were using, have a day remote working remotely, and this helped move into COVID, but COVID changed that more rapidly, I believe. And future leaders have expectations from the employers that they provide the tools and the education in actually using the softwares and the tools that we are currently using in our jobs to be able to do it from day one, and providing an encouraging environment for thoughts, initiatives, and of course, being paid salary. We'll link into customers and employers in a second. So next slide, please. The current market needs, we are getting more and more complex projects with the interaction of many different specialities, the interactions of many different generations, and also technologies. So we have changing technologies. Many different companies are using different software solutions, and the interaction of these softwares within delivery of projects is also an interesting thing. So engineers are being required to be more and more IT savvy, not only focus on engineering, the technical part of it. COVID, I think, had, especially in my part of the world, a tremendous impact on project delivery, because everything got very dynamically pushed to mobile and remote work and cloud computing. So even where public clients in my part of the world were more skeptic about, delivering projects remotely, they have had to open this because it's been already a year, and no project would have moved ahead if it wasn't for remote delivery. Of course, this has put a stress on human interaction and communication, which for young people is in general something that's required at work, the social aspect of it. There are new services that are being provided, and this was before COVID also. The engineers are acting as data miners for statistic analysis. Engineers are acting as lawyers when they have to be contract managers and deal with subcontractors or contractors in general. Engineers are also financial specialists when it comes to optimizing cash flow on projects or loans or feasibility studies and so on, and their impact on that. So next slide, please. And this has an impact, of course, on employers. So employers need future leaders and young professionals or engineers who can deliver what was shown on the previous slide. So it's not only technical and classical engineering work, it's public speaking element of our job, which is interacting with clients and suppliers, is negotiation skills when it comes to signing subcontract agreements or services agreements, It's understanding that there is a cash flow in every project, whether it's a service project, whether it's a contract project, you need to sell the work. And it's conflict resolution, ultimately also some sociology element of the job. Connecting with education institutions has been big also in Poland and in Eastern Europe. So companies are now more and more reaching down to universities to catch talent earlier. So the proposed sandwich studies, for example, where you spend a semester working and a semester learning or online learning while you're at work. This is something that's really interesting. Technology savvy graduates, so that they can actually use Zoom and know how to share their screen and things like this. Problem solving driven education and so on. So how in Poland, it's been a lot of case study projects. So the students are actually starting to do real projects while they're at university. So this is also, I saw in the framework, adding non-technical curriculum, which is also proposed as a change in the framework, and contemporary data analysis, which also was proposed in the change to the framework, which leads to my next slide, please. As Dr. Kanga pointed out, the larger themes that were changed all fit in nicely with this change from market that came from the research done by WFEO, and also which parallels to the proposed certificate program done by FIDIC, which is accommodating future needs of engineering professionals, which Dr. Kanga mentioned, emerging technologies with COVID and cloud computing and BIM, emerging future engineer disciplines like engineering data miners, incorporated UN sustained goals, which are needed for the young professionals and future leaders to feel engaged in work and their work to actually have meaning and changing their environment. Diversity and inclusion, there's more and more female presence in the workplace, and this is all over the world. And not only female, but race is important also. Intellectual agility, creative and innovation, is everything that young people really drive for, and the idealism that they want to leave behind. So next slide, please. I think that sums up what I had to say. So thank you very much. And thank you. Pleasure to be able to speak with you all today.
Thank you. Thank you, Adam. And thanks to all previous speakers for your excellent presentation. And from your speech, we do see a good match of the work done by the WFEO project and your work in FIDIC. Actually, 20 years ago, when I worked in Tsinghua University, China, I have involved with FIDIC to organize your training courses in China. That was a very standardized training, very impressive. So we still have a few minutes for questions and answers, perhaps also from the panelists on the board to give further remarks. I see there is a comment in the chat box about risk management. Could Charlie or Marlene give comments, response to this comment? Risk management.
Yes, I might comment on that. I didn't go through the details of the graduate attributes, but risk, considering the risks at the conceptual stage when you're developing solutions for students is part of the graduate attributes framework. And therefore, and also in the continuous professional development, managing risks in terms of the environment, as well as the impacts on society, is part of the professional competency framework. So it is definitely there. It may not have been stated explicitly in the professional competency framework, but it is certainly a very important part of the skills that an engineer needs to have.
Thank you, Marlene. Any further comments from the board?
Yes.
So yeah, please, Charlie.
Yeah, and for the professional competency, the working group includes evaluate the outcomes and impact of complex activities in the context of risk and social, environmental, economic, and resource impact.
Yeah.
This is included in the evaluation type of the activity, not only in the engineers, but also for the engineering technologies. Thank you.
Yeah, thank you, Charlie. Actually, the risk management is exists in the current GAPC, and I think the amendment is to reinforce risk management, not limited to technical risk, but also social, cultural, environmental considerations. I think that's very important today. So we see some other questions on the Google Doc sheet. Ivan, could you show that on screen? Oh yes, this is too small to see. Can you read it? Make it larger. Oh, it's better. More larger. I think here is a question about how to estimate the effect of development of planning for example, beam technology and new construction methods like 3D printing in the future of some branches, especially go right hand. Anyway, I think we can get the idea of this question. That is about the new technologies such as 3D printing, the building information model, how to estimate the impact of that. If anyone from the panel can answer this question?
This is in terms of, I think the question is in terms of contract management and whether BIM and the use of new technologies will reduce conflict, if I understand the question correctly, and reduce claims due to a reduction in errors in construction. I think that's my understanding of the question. So perhaps someone from FIDIC might want to take that.
Oh, this is Bill Howard. One thing I would comment on it is that risk is always so very, very important. And whenever I think of BIM and IT, the evolution of IT tools, I think there's a growing expectation among a lot of our owners and clients that when they retain an engineer for the design of something using these tools, just as you mentioned, Marlene, there's almost an expectation of perfection, and the tools are there to provide a lot of technical, somewhat guarantees that that there won't be a lot of claims and errors and omissions and that kind of thing. But that creates risk to the engineer as well, to make sure that whatever they're developing in the BIM world is the right thing. So I think some of the claims that may be coming in the future is, you've prepared a design that is, quote, almost perfect, but it's not exactly fit for purpose, or doesn't deal with some other broad concept. So I don't know if that gets at the question, but I think the risk might be slightly different as we look into the future.
Thank you, Bill, for your comments. And I see here in the chat box, there's a comment about communication skills. Would Charlie or Marlene respond to this comment about soft skills?
Yes, I think this is a very important change. Engineers increasingly need to communicate their solutions, how they've approached the problem and how they've developed the solutions. Traditionally, engineers just did the numbers, did the math, and they didn't talk very much, and they left the talking to other people. But now, I think this has become a very important skill. And in fact, it's not just, it's written reports, presentations, and so on that is actually specified in both the graduate attributes and in the professional competencies. This is a very key competency that is being demanded increasingly. And also being able to communicate in different contexts, in different cultures, and if it's in a learning mode, taking into account that people learn differently, and so the communications need to be presented in different ways. It's a very, very important part of the change and the emphasis on communication.
Yes. And Marlene, if I could just quickly elaborate on that. Please. Too. And the companies, I know my company in particular spends a lot of time training mid-level engineers on communicating. We happen to work with the public sector a lot, where I think that's particularly essential. And I guess in the shortest point is that if they're not learning it in the university, the companies will definitely be training them in that area. It is so critical that engineers know how to communicate.
Yes, the communication is so important, especially for the future engineers. They would work in a multidisciplinary team, even international team. Effective communication between different disciplines and different cultural background is so important for the success of engineering design and engineering works. So I think we have go over the time of the webinar. Please allow me to close this webinar with two notes. The first is that please continue to post your questions and comments to the question sheet. That will be responded after the webinar. And the second note is please go to the World Federation of Engineering Organizations, WFEO's website. There you could find the complete report of the proposed amendment to the GAPC of IEA. And your comments and your further suggestions would be highly appreciated. Also, the presentation slides will be shared on the consultation page of WFEO website. So with sincere thanks to all panelists and all participants, please allow me to close this webinar. Have a good day and keep safe and healthy to all of you. Thank you, bye-bye.
Bye-bye.
Thank you.
Thank you for joining us. Thank you.
Yeah, thank you for joining us. Thank you, Charlie. You are now in the focal point of the world, and your organization still working and complete your functions. Thank you so much.